conditional probability and the multiplication rule. All right, let's go to work. So we're going to be talking about the probability of an event given another event. That's what conditional probability is. So simple probability is favorable over total, but we'll be talking about conditional probability today. How to distinguish between independent and dependent events, as well as how to use the multiplication rule to find the probability of multiple events happening. First, what is conditional probability? It is the probability of an event occurring given that another event has already occurred, denoted by probability of B given A. Think of the line as the word given. So probability of B given A. Here's an example. 2 cards are selected in sequence from a standard deck. Find the probability that the second card is a queen, given that the first card is a king. Okay, assume that the king is not replaced. Here's what you got to realize. Because the first card is a king, you have to assume that the first thing happened. Okay? No matter what, you have to assume that the first thing actually happened. So because the first card is a king and it's not replaced, the remaining deck only has 51 cards because we took 1 card out and kept it out. So there are 51 cards left, and there are still 4 queens. We took out a king. So you have to assume on your first item it actually happened. So your probability is then 4 out of 51, or 7%, or almost 8%. That is conditional probability. For example, here's another example. This table shows a survey in which 2,276 social media users were asked whether they have been offended by something they saw on social media. Find the probability that a user is male, given that the user was offended by something on social media. So first, we are going to talk about the males, which is 532, but there's 1,151 total users who were offended by something on social media. So we're only looking at that one side. Okay? So the sample space consists of 1,151 users, and of those, 532 are males to get 46, or 0.462, or 46.2%. Independent events are 2 events that happen totally separate from each other, and one has absolutely no effect on the other. Okay? And it's written this way. Probability of B given A equals the probability of B, or probability A given B equals just the probability of A. If events aren't independent, they must be dependent. So let's say I have a spinner and a die. And I'm going to spin the spinner and I'm going to roll the die. Are those dependent or independent events? Independent. Let's say I have a deck of cards and I want to pull out a king and then I want to pull out a queen. Are those independent or dependent? Dependent, because my odds are going to change on the second event depending on what happens on the first. Okay. So let's decide whether this is dependent or independent. Selecting a king from a standard deck, not replacing it, and then selecting a queen, we've already said that is dependent. What if I replace the card? All of a sudden it would become independent. Okay. Tossing a coin, getting heads, and then rolling a 6-sided die and getting a 6. Independent. Okay. Driving over 85 miles per hour and then getting in a car accident. Dependent. Driving over 85 increases your chances of getting into a wreck. So the multiplication rule is just as it sounds. When you have the probability of 2 events, you're simply going to multiply those probabilities. Doesn't matter whether it's independent or dependent. You're going to find both probabilities and you're going to multiply. Now, no matter how many independent events, you can multiply it together, no matter how many times there are. So here's an example. Find 2 cards that are selected without replacing the first from a standard deck of 52 cards. Probability of getting a king would be 4 out of 52. The probability of getting the queen, as we talked about earlier, is 4 out of 51. The multiplication rule says you take those two probabilities, multiply them together. 4 times 4 is 16. 2 times 51 is 2652. And then your percentage is 0.06. Excuse me, 0.6%. That's the multiplication rule. Probability of a coin toss getting heads and a die getting a 6. Probability of getting heads is 1 out of 2. Probability of rolling a die and getting a 6 is 1 out of 6. Yes. 1/2 times 1/6, 1/12. Kind of feels like we're back in 6th grade, doesn't it? Simple enough. Questions on independent, dependent, or the multiplication rule. That's 3.2. That's 3.2. Last thing is a complement. The complement of an event is 1 minus that probability. For example, find the probability of a randomly selected senior has matched to a residency position, did not get matched with one from the senior trip with 3 choices. So the probability of that was 72.9 or 0.729. To find the complement of that, you just subtract it from 1.